So I want you to picture this. It's July 4th, 1942.
Right.
And there's this American pilot, Charles Kaleman, and he's flying just like feet above the ground over occupied Holland, broad daylight.
Yeah, and the situation is just completely catastrophic at this point.
Totally. I mean, his right wing is literally on fire. German anti-aircraft rounds have just torn into it. An enemy shell actually hit the plane and completely sheared off one of his propellers.
Ripped it right off.
Exactly. So by every rule of aerodynamics, survival instinct, whatever manual you want to read, he should be pulling back on the yoke, right? Trying to get altitude so he can bail out.
Which is standard procedure, yeah.
Right. But instead, he's in this crippled, burning, completely asymmetrical twin-engine bomber, and he pushes the nose forward.
It's unbelievable.
He steers the burning plane directly into the teeth of the German flak tower that just shot him. Like, he takes them head on.
Yeah.
And amazingly, he somehow survives, nurses this flaming wreck back across the English Channel, and earns the Distinguished Service Cross.
I mean, it is just one of the most audacious, kinetic moments of the early American Air War in Europe.
Absolutely.
But, you know, what makes that moment even more remarkable to me is the actual aircraft Kegelman was flying.
Right, because it wasn't what you'd expect.
No, not at all. It wasn't the legendary B-17 Flying Fortress, and it wasn't a nimble P-51 Mustang.
Nope.
It was a plane that, honestly, most casual history buffs couldn't even pick out of a lineup today.
So, welcome to the deep dive. Today, we're really getting past the surface level trivia of the Second World War. We have just a mountain of operational reports, historical analysis, pilot accounts.
So many primary sources.
Yeah, and they all surround a machine that was basically the absolute definition of a historical blind spot, the Douglas A-20 Havoc.
The Havoc.
Right. And our mission today for this deep dive is to explore how an airplane that the U.S. military didn't even initially want, an aircraft that was ordered by foreign militaries.
And delivered without weapons.
Right, delivered without proper weapons.
Right.
How did that become the most devastating, low-level attacker of the entire war?
You know, the story of the A-20 is really a study in pragmatic engineering. It's about tactical evolution. Because when you look at the origins of this aircraft, it didn't start out as this highly classified, bleeding-edge American project, you know. It wasn't designed to win a global conflict.
Wait, really? So where did it come from?
Well, back in 1938, the Douglas Aircraft Company designed this twin-engine light bomber. They internally called it the DB-7, and they built it primarily with the export market in mind.
Oh, wow. So they were just trying to sell it overseas.
Exactly. France was desperately trying to modernize its air force at the time, and they bought the DB-7 to use as a traditional medium-altitude level bomber.
Which makes sense for them. I mean, the French military doctrine back then was notoriously rigid.
Oh, incredibly rich.
They looked at the DB-7 and saw a standard bomber. You fly it straight, you fly it high, and you drop bombs on a target using a bomb sight.
Very detached,
Okay.
very mathematical.
Yeah, very mathematical way to fight a war. But then the British Royal Air Force gets involved, right?
Right. The British buy a bunch of these aircraft, too. And keeping with their tradition of naming bombers after cities, they start calling it the Boston.
About Boston. I like that.
But the thing is, the British look at the exact same machine that the French have, and they see something entirely different.
Okay, let's unpack this. What did the British see that the French missed?
Well, they recognized the inherent kinetic potential of the airframe itself. I mean, the DB-7 had these twin radial engines, a very sleek fuselage, and tricycle landing gear.
Which was a big deal back then.
Huge deal in the late 1930s. It gave the plane a level of speed and maneuverability that was just incredibly rare for a twin-engine bomber.
Right.
So the British realized that flying this thing straight and level, way up high, was just a total waste of its capabilities.
Yeah.
They immediately adapted it for low-level, high-speed ground attack missions.
I mean, it's like buying a high-end, insanely capable sports car, but it has rally suspension.
That's a great way to put it.
The French bought this sports car, and they used it for a speed limit-abiding highway commute. But the British got the keys, took one look at the suspension, and immediately drove it into the mud just to see how it handled off-road.
And, you know, watching the British tear across the landscape like that finally woke up the United States Army Air Corps.
About time.
Seriously. In 1940, the U.S. Army ordered 300 of these aircraft. They gave it the designation A-20, and they officially dubbed it the Havoc.
The Havoc, which is just a fantastic name.
It really is a profoundly fitting name. But, as we'll see, having a capable airframe is really only the first step.
Right, because the American military in 1940 and 41 was well, it was deeply fractured over how air power should even be used.
Extremely fractured. You had the bomber mafia, these factions obsessed with high-altitude
Yeah,
precision daylight
the
bombing.
guys who love the heavy bombers.
Exactly. And to them, ground attack and low-level flying were viewed as dangerous secondary tasks.
Almost like a relic of trench warfare, right? Just strafing runs from World War I.
Yeah, exactly.
Yeah.
Which sets the stage for the absolute administrative whiplash that the first American A-20 pilots experienced.
Oh man, the mix-up. So for context, the 3rd Attack Group had been training with the A-20 down in Savannah, Georgia.
Mm-hmm.
But the plane's very first taste of combat with American pilots actually happened in Europe. And it started with a massive logistical blunder.
It really did.
So the 15th Bomb Squadron is sent over to England. They're supposed to join the mighty 8th Air Force and, gain some combat experience.
Right.
They cross the Atlantic expecting to fly a very specific variant of this plane, the P-70.
And the P-70 was the night fighter modification of the airframe.
Right.
So you have to put yourself in the mindset of these American crews. I mean, for you listening, imagine spending months training to fly in pitch black condition.
Relying on early clunky radar equipment.
Exactly,
Yeah.
using rudimentary radar to stalk enemy bombers in the dark. It is a highly specialized, almost surgical type of flying.
But they show up in England, and the Royal Air Force essentially just looks at them and says, yeah, we aren't using the Boston as a night fighter anymore.
The tactical environment had completely shifted.
Right, so these American radar stalkers are abruptly reassigned to a daytime attack role.
Overnight.
Literally overnight. They're told to throw out their entire playbook, hop in the cockpit with RAF crews, and learn how to fly zero-altitude, high-speed daylight missions over occupied Europe.
And the transition had to be immediate.
Yeah.
Because by the summer of 1942, the pressure for the Americans to actively engage the enemy in Europe was immense.
People were demanding action.
Right. And that brings us to that July 4th mission we talked about at the start.
The Kegelman mission.
Yeah. The mission was a low-level daytime attack on German airfields in Holland. 6 American crews joined 6 RAF crews. But, we really have to understand the specific lethality of the airspace they were entering.
Oh, for sure. Because flying low over Holland in 1942 meant you were flying directly into the teeth of the German anti-aircraft network.
The flak defenses.
Right, the flak. And when we talk about flak, it wasn't just one type of gun. The Germans had a layered defense system.
They really did. It was meticulously structured. At high altitudes, you dealt with those infamous 88-millimeter cannons.
Which fired large explosive shells that burst at predetermined heights, right?
Exactly. So by flying right on the deck, the A-20s undercut the effective engagement envelope of those heavy 88s.
Oh, so the big guns couldn't even aim at them.
Right. The heavy guns literally couldn't track a fast-moving target that low or depress their barrels far enough to hit them.
But the trade-off, and this is a brutal trade-off, is that by flying at 50 feet, you enter the engagement zone of literally everything else.
Everything.
You're talking about the 20-millimeter and 37-millimeter rapid-fire cannons, heavy machine guns, and even just standard infantry rifles.
Yeah.
When you are that low, every single soldier on the ground who has a weapon has a clear shot at your airplane.
And that is precisely the meat grinder that the 15th Bomb Squadron flew into.
It's terrifying.
Which is, out of the 6 American crews that participated, only 2 managed to successfully bomb their assigned targets.
Oh, wow.
2 American planes were shot out of the sky entirely. And then you have Captain Kegelman's plane, catastrophically damaged, fighting its way out.
So that's a 50% casualty rate on your very first combat outing. In a purely tactical sense, that is a disastrous raid.
It's terrible.
You lose a third of your strike force and barely even touch the targets.
Tactically, yes, it was a failure. But strategically and psychologically, if we connect this to the bigger picture, the raid was indispensable.
How so?
Because that July 4th mission proved to the British, to the Germans, and frankly to the American public, that the United States Air Force was finally in the fight in Europe.
Ah, I see.
It demonstrated this raw level of sheer resilience. Kegelman pushing his burning plane into a flak tower wasn't just him surviving, it was a statement of intent.
Like they were willing to take heavy losses and still press the attack.
Exactly. It's the ultimate "we have arrived" moment.
That makes total sense. But, while the A-20 crews in Europe were learning these brutal lessons about layered air defenses, a completely different, almost absurd crisis was unfolding on the other side of the world.
Oh, the Pacific Theater?
Yeah, the Pacific. Over in Europe, they're fighting the Germans and the flak. But in the Pacific, in mid-1942, the Allies are fighting distance, the jungle, and just a completely broken supply chain.
I mean, the Southwest Pacific Theater was basically the very end of the longest supply line in the history of warfare.
Right.
The Japanese military had swept across the Pacific with terrifying speed. American and Australian forces were operating on an absolute shoestring.
Just throwing whatever assets they had at the defense of New Guinea.
Just to protect Australia, exactly.
So the third attack group, those guys who'd originally trained on the A-20 back in Georgia, they get ordered to Australia.
Right.
But because of shipping delays, the men arrive months before their airplanes do.
They're just sitting around waiting.
Yeah, just sitting there. Finally, in early August 1942, a cargo ship arrives in Australia. 24 brand new A-20 Havocs are unloaded onto the docks.
The relief must have been incredible for those guys.
Oh, it had to be. But then, the ground crews actually inspect the planes. And they realize these brand new bombers are completely useless for combat.
It's just staggering. The 24 aircraft arrived without any machine guns installed and without any bomb racks.
Wait, really? How does that even happen?
Well, the industrial base in the U.S. was ramping up so incredibly fast.
Right.
Different components were manufactured in different factories all across the country. So the fuselage gets put on a boat in one port, but the guns and the bomb racks completely miss the shipment.
It just boggles the mind. You have 24 highly advanced combat aircraft sitting in a desperate war zone, and they are effectively just really fast, really expensive transport planes.
Pretty much. And, in a rigid theater command, those planes would have sat on the tarmac for 6 months.
Just waiting for the proper administrative channels to send the missing parts.
Exactly. But the Southwest Pacific was commanded by Lieutenant General George C. Kenney.
Kenney was a different breed.
He was. He was an innovator. A pragmatist. He understood that their desperation required unconventional solutions.
Yeah.
So he gave his subordinates immense latitude to solve problems using whatever scrap they had available.
And that specific environment perfectly suited the man Kenney put in charge of the 3rd Attack Group's mechanics.
Oh, Pappy Gun.
Captain Paul Irving Gunn.
Yeah.
Pappy Gunn. I mean, if there is a patron saint of field engineering in the military, it is absolutely this guy.
No question.
Gunn wasn't some, academy-trained, textbook-following aeronautical engineer.
Not at all.
He was a former U.S. Navy enlisted aviator. He was a machinist's mate who had literally been running a private commercial charter service in the Philippines before the war broke out.
He was a scrounger.
Yeah.
Pappy Gunn is a legendary figure because he looked at military hardware not as a finished, untouchable product, but as raw material. So when Gunn inspected those unarmed A-20s, he knew the original design called for .30 caliber machine guns.
Right.
But Gunn had flown extensively in the Pacific. He knew the enemy. He realized that the standard .30 caliber weapon, which fires a relatively small projectile, was completely inadequate.
Because the primary mission in the Pacific was destroying Japanese shipping.
Exactly. A .30 caliber bullet might punch a hole in the canvas of a truck, but against the steel hull of a cargo ship, or the armored deck of a troop transport,
It's just going to bounce right off.
it's useless.
Yeah.
You needed something that could punch through steel and destroy the machinery inside. Gunn knew they needed .50 caliber heavy machine guns.
And luckily, there's a ready supply of forward-firing .50 calibers just sitting around in Australia, right?
Yep. Salvaged from wrecked fighter planes.
But wait, how does a rogue mechanic just decide to fundamentally redesign an army bomber in the middle of a war zone?
Well, this is where Gunn's genius for improvised engineering really shines. The A-20, as it was originally designed, featured this large, glass-enclosed nose.
The greenhouse nose!
Right. The bombardier was supposed to sit in that greenhouse, looking down through a bomb site to direct high-altitude drops. Gunn decides to completely gut that forward compartment. He just rips it out.
Oh.
And he proposes packing 4 massive .50 caliber machine guns directly into the nose of the airplane, plus mounting 2 additional .50 calibers in specially fabricated external pods bolted right to the sides of the fuselage.
Okay, let's talk about the physics of that for a second.
Yeah.
Because bolting 6 heavy machine guns to a light bomber isn't just a matter of, using enough duct tape.
No. That's
The
right.
recoil force of a single Browning M2.50 caliber machine gun is immense. It produces violent vibration and heat. Gunn is taking 6 of these weapons and attaching them to an airframe that was never structurally designed to handle that specific concentrated stress.
It's an incredible feat of structural engineering.
All right.
And they did it on a dusty hangar floor.
Right.
Gunn and his mechanics had to build a rigid internal truss system within the nose. They tied the gun mounts directly to the main structural bulkheads of the aircraft.
So the recoil wouldn't literally just tear the nose off the plane when the pilot fired.
Exactly. They had to figure out how the center of gravity would shift. They had to design complex ammunition feed chutes so the belts of heavy .50 caliber rounds wouldn't jam under the G-forces of a combat turn.
That is wild. And they had to synchronize the firing mechanisms, right? So the pilot could trigger all 6 guns simultaneously from the yoke.
Yeah, and the result of this hangar floor engineering was absolutely terrifying.
I bet.
The Bombardier was gone. The A-20 was no longer an aircraft that flew over a target and dropped things politely.
No.
It was an aircraft that flew straight at a target and unleashed an absolute torrent of armor-piercing lead. It was basically a flying chainsaw.
A flying chainsaw. I love that. So Gunn converted a light bomber into a heavy strafer.
He did.
But as revolutionary as that 6-gun modification was, it was really only one half of the equation, wasn't it?
Right. It was half the equation that would make the A-20 a legend in the Pacific. Because General Kenny, the theater commander we mentioned, had his own lethal invention waiting in the wings.
Yeah, so before the war, Kenny had been heavily involved in the research and development branch of the Army Air Corps. And during that time, he championed a highly specific, very peculiar weapon, the parachute fragmentation bomb.
Also known as the parafrag.
The parafrag. Here's where it gets really interesting for anyone listening. Explain the physics of this thing.
Well, the parafrag was designed to solve a fundamental physics problem in aerial warfare. The extreme danger of low-level bombing.
Right.
Think about it. If a pilot is flying at 50 feet off the ground at 250 miles an hour, and he drops a standard high-explosive bomb...
The bomb hits the ground and detonates almost instantly.
Exactly. And because the aircraft is flying so low and so fast, it will literally fly directly into the blast wave and the shrapnel of its own munition.
Which is essentially dropping a grenade at your own feet. It's a suicide run.
Yeah, you blow yourself out of the sky.
But you want to bomb at low altitude because it's incredibly accurate.
Right. You can drop munitions right on top of dispersed targets, troops hiding under the jungle canopy, or airplanes parked under camouflage netting.
But the physics of standard bombs just prevent it. So Kenny's solution, the parafrag, was this small 27-pound fragmentation bomb suspended under a parachute.
Right. The parachute acts as an aerodynamic retardant.
Okay.
The pilot comes in right on the deck. He releases the bomb. The parachute deploys immediately, catching the airstream and drastically slowing the bomb's forward and downward momentum.
Wow.
So the bomb basically floats to the ground on a delay. And that delay, which is just a few crucial seconds, gives the low-flying A-20 enough time to safely clear the blast radius.
That is brilliant.
When the bomb finally hits and detonates, it shatters into thousands of lethal, high-velocity fragments, sweeping the ground. And the attacking plane is already miles away.
So Kenny had a stockpile of these bombs sent to Australia.
Yes, he did.
And when he visited the 3rd Attack Group at Charter Towers and saw what Pappy Gunn had done with those 6 forward-firing .50 calibers,
He immediately recognized the synergy.
he saw an aircraft that could suppress the enemy with overwhelming forward firepower while simultaneously dropping delayed action fragmentation bombs directly on their heads.
It was the perfect match. They actually decided to test the combination in a wooded area near Charter Towers.
What happened?
Well, Gunn took a modified A-20 up. He came in low over the trees and just opened up with the 6.50 calibers. The concentrated firepower literally ripped a physical swath through the timber.
Just turn the trees to sawdust.
Yeah. Then he dropped a string of parafrag bombs. The parachutes deployed, the bombs settled into the shredded canopy, and they detonated.
Oh, man.
The combined effect turned the entire test area into absolute splinters. Kenny and the group commander, Colonel Davies, watched this display, and they instantly knew they had a weapon that could alter the dynamic of the ground war.
And the timing on that couldn't have been more critical, because the ground war in New Guinea was on the verge of total collapse.
It really was.
It's September 1942. The Japanese forces have landed on the northern coast of New Guinea, and they are pushing south over the incredibly rugged Owen Stanley Mountains along the Kokoda Track. Their objective is Port Moresby, right on the southern coast. And if Port Moresby falls, the Japanese have a direct staging ground to threaten the Australian mainland.
The stakes were massive, and the Japanese advance was just relentless.
Right.
They had already captured a village called Yurubaiwa, which was just 30 miles from Port Moresby.
Mm-hmm.
The Allied ground forces were completely exhausted,
Yeah.
and the situation was deeply in doubt.
Yeah. And the Japanese were operating under the established doctrines of air warfare. They assumed American bombers would fly high overhead, dropping these large, unguided bombs that would just get absorbed by the dense jumble
Right,
canopy.
they felt relatively safe under the trees.
But on the morning of September 12, 1942, those old rules of warfare were violently rewritten.
They certainly were.
A formation of 9 modified A-20 Havocs from the 8th Bomb Squadron, led by Captain Don Hall, attacks the advancing Japanese forces at a place called Buna. That was their main supply hub.
So try to conceptualize the sheer shock of this attack from the perspective of the Japanese infantry on the ground.
Right.
You're relying on the dense jungle for concealment. Suddenly, you hear the roar of twin radial engines. But they aren't echoing down from 10,000 feet.
No.
They're tearing directly through the treetops right above your head.
9 aircraft roaring in at 0 altitude. Each plane is carrying those 6 heavy machine guns, and each plane is packed with 40 parafrag bombs.
40.
Yeah, 40. The startled Japanese troops are caught completely exposed. The A-20s sweep over the encampments, the machine guns chew up the ground, the supplies, the personnel, just a continuous wave of lead.
And then instantly behind that wave of bullets, hundreds of parachutes deploy.
Dropping fragmentation charges directly into the troop concentrations.
The tactical surprise was absolute. There is no taking cover from an attack that is happening simultaneously from the front with armor-piercing rounds and from directly above with air-bursting fragmentation.
It's devastating.
Completely. The Japanese advance was instantly paralyzed. This single tactical innovation combining a modified airframe with a specialized munition cut the Japanese supply lines from Buna almost overnight.
Wow.
The air forces at Buna and Leh were rendered ineffective. The Japanese drive on Port Moresby halted entirely, and they were forced into this grueling, miserable retreat back up the Kokoda track.
And the A-20s harried the retreating columns relentlessly, right? So they basically acted as flying cavalry, turning a tactical retreat into a full rout.
Yeah.
Even the Japanese commander himself, General Hari, was killed when A-20s attacked his position at the Kumuzi River Bridge. They literally dumped him and his element right into the water.
It is such a profound example of how wars are often won. For you listening, think about how often a minor structural change in a project or a business yields exponential results. Gunn and Kenny didn't invent a new plane from scratch. They didn't spend billions of dollars on R&D. They looked at existing, flawed tools, and they combined them in radically new ways.
They changed the relationship between the machine gun, the airplane, and the bomb. And in doing so, they literally halted an invading army.
Right.
But the A-20's evolution in the Pacific didn't stop at the jungle canopy. As devastating as they were against infantry, the true lifeblood of the Japanese Empire was its maritime logistics.
No, absolutely. The cargo ships, the troop transports, the destroyer escorts that connected all their island conquests.
Rah.
And to sever those arteries, the A-20 crews perfected a tactic that sounds completely insane but was mathematically lethal. Skip bombing.
Skip bombing. So I love explaining this. For anyone trying to picture skip bombing, imagine standing on the shore of a lake and skipping a flat stone across the water. You throw it sidearm, low and fast, and it bounces across the surface. Now replace the flat stone with a 500-pound high-explosive bomb. Replace your arm with an aircraft flying at 250 miles an hour. And replace the calm lake with the open ocean, where you are aiming at the broadside of an armored warship.
It's just wild.
Yeah.
The precision required from the pilot is staggering.
Because if you mess up even slightly, you're dead.
Exactly. If you drop the bomb from too high an altitude, it hits the water at a steep angle and simply sinks.
Useless.
If you drop it too low, you risk clipping a wave and crashing the aircraft into the ocean at 250 miles an hour.
Right.
The pilot has to approach the target ship, flying perfectly level, roughly 50 feet above the waves. He releases the bomb hits the water, skips across the surface of the ocean, and slams directly into the side of the enemy ship.
But there has to be a specific fusing mechanism involved, right? Because if the bomb hits the steel hull and explodes instantly, the resulting blast and fragmentation will take out the attacking A-20 flying right over it.
Exactly right. The bombs were fitted with delayed action fuses, usually set for about 4 to 5 seconds. So the bomb skips across the water, strikes the hull of the ship, and its forward momentum actually causes it to sink slightly beneath the waterline, right next to the hull. Then, the delayed fuse triggers the detonation.
And hydrodynamically, a detonation right below the waterline is the holy grail of anti-shipping combat.
It really is.
Because an explosion in the air just damages the deck. But an explosion underwater creates a massive gas bubble that expands and collapses violently.
Right.
The resulting shock wave transfers directly into the unarmored lower hull, breaking the ship's keel or punching a massive hole that lets in hundreds of tons of seawater. The ship doesn't just burn, it breaks its back and sinks.
But the primary obstacle to skip bombing is the approach itself.
Of course.
Flying straight and level at 50 feet toward a military vessel means you are flying directly down the barrel of every single anti-aircraft gun on that ship.
Yeah, the gunners have a perfect zero elevation shot right at you.
This is exactly where Pappy Gunn's .50 caliber nose modifications transformed the A-20 from a vulnerable bomber into a completely self-contained strike package.
Oh, because as the A-20 pilot is roaring in on his skip bombing run, he isn't just a sitting duck.
Not at all.
He's holding down the trigger, firing those 6 forward-facing heavy machine guns. He's raking the deck of the enemy ship with thousands of rounds of armor-piercing ammunition.
Yes, he is physically tearing apart the anti-aircraft emplacements, killing the gun crews, and completely spoiling the aim of anyone left standing.
So the A-20 basically provides its own suppressing fire to create a safe corridor to deliver the bomb.
Exactly. And all of this tactical evolution, the low-level flying, the skip bombing, the heavy strafing, it all culminated in March of 1943 at the Battle of the Bismarck Sea.
Oh, this battle is legendary.
It's a textbook masterclass in coordinated, multi-layered air-to-sea warfare.
So what happened?
Allied codebreakers intercepted intelligence that a massive Japanese convoy troop ships, heavily protected by destroyer escorts, had set sail from Rabaul to reinforce the Japanese stronghold at Leh.
And if those reinforcements landed, the Allied campaign in New Guinea would be severely compromised.
Severely. So the 5th Air Force was tasked with stopping them, and they threw everything they had at the convoy in a meticulously choreographed assault.
It was a layered attack, right?
Yes. First, you have the heavy B-17 flying fortresses coming in from high altitude. Now, their bombs might not score many direct hits on moving ships, but the high-altitude threat forces the Japanese convoy to break its tight defensive formation.
They have to start taking evasive maneuvers.
Right, it sows chaos. Then, coming in below the clouds at medium altitude, the B-25 Mitchell's attack, pouring destruction onto the scattered transports.
So the Japanese anti-aircraft directors are completely overwhelmed. They're looking up, trying to track heavy bombers at 10,000 feet and medium bombers at 4,000 feet.
Their formation is shattered. And then, at the absolute lowest level, literally skimming the whitecaps of the ocean, the A-20 Havocs arrive.
They come in completely under the radar, quite literally. Captain Ed Shudoba lines up on a large cargo ship. He comes in right on the deck, his guns blazing, and skips his bombs directly into the broadside of the vessel.
And right behind him, Captain Glenn Clark targets a destroyer.
A destroyer.
Yes, and remember, a destroyer's sole purpose in a convoy is to protect the transports with heavy anti-aircraft fire.
Right.
Clark flies his A-20 straight through that defensive fire, suppresses the deck with his .50 calibers, and skips 2 500-pound bombs directly into the aft section of the destroyer.
Wow.
The explosions blow a massive hole in the stern, and it immediately begins to sink.
I mean, to manually fly an unguided munition into the stern of an evading, heavily armed warship while taking fire at wave-top height, it requires a level of piloting skill and sheer nerve that is difficult to even overstate.
It's incredible. And the other A-20 crews mirrored this success, scoring direct hits all across the scattered convoy. The aftermath was total devastation. The combined strikes sank 5 ships and left 6 others burning out of control.
Combined strikes sinking 5 ships. I mean, Samuel Eliot Morison, who is the preeminent naval historian of the Pacific Theater, he called it the most devastating attack by aircraft on ships of the war.
It really was. The Battle of the Bismarck Sea was a massive strategic paradigm shift.
It proved definitively that land-based air power could unilaterally obliterate an organized naval fleet.
Exactly. What's fascinating here is that the strategic implications reverberated all the way back to Tokyo. After the Bismarck Sea, the Japanese High Command realized they could no longer safely move large troop convoys through the contested waters of the Southwest Pacific.
Wow. The Allies had effectively built a wall across the ocean using modified light bombers.
They did. The Japanese never again successfully reinforced New Guinea by sea.
It's an incredible triumph of tactical innovation. But you know what's absolutely wild about the history of the A-20 is that while George Kenney and Pappy Gunn were rewriting naval warfare in the Pacific, A completely different philosophical battle over how to use this exact same airplane was taking place over in Europe.
The European and Mediterranean theaters.
Yeah, because the military is this vast, decentralized bureaucracy, and different theater commanders face different realities and hold different doctrines. So if we shift our focus to North Africa, we see the 47th Bomb Group operating the A-20.
And initially, they're utilizing it in the low-level tactical ground support role that the British had originally envisioned.
Right. Like during the Battle of Kasserine Pass, which was a massive armored engagement in the desert, the A-20s flew multiple critical missions. They were skimming the dunes and attacking advancing German tank columns.
They were highly effective. They actually earned a distinguished unit citation for their work there.
So they're proving the concept works against armor in the desert just as well as it works against ships in the Pacific.
Yep.
But then the command structure changes. General James H. Doolittle, Jimmy Doolittle, the architect of the famous Tokyo raid, takes command of the 12th Air Force in the Mediterranean.
Right.
And Doolittle looks at the A-20 operations and fundamentally disagrees with the low-level doctrine. He orders a complete reversal of the tactical evolution we just spent 20 minutes discussing.
He did. Doolittle was vehemently opposed to low-level operations in his theater. He looked at the casualty rates, the loss of experienced air crews, and decided the tactic was unsustainable. So he ordered the A-20 and B-26 groups under his command to cease all low-level flying. He commanded them to operate exclusively as medium-altitude level bombers.
He literally ordered the mechanics to pull the planes apart and reinstall the intricate Norden bomb sights in the nose.
Yeah, completely reversing Pappy Gunn's work.
He took enlisted men who were trained as mechanics and tail gunners, rushed them through bombardier training, and stuck them back in the glass greenhouse to drop bombs from altitude.
It's a huge shift.
I have to push back here, though, because from a purely engineering standpoint, this seems like madness. You have an aircraft that has proven it can sink a fleet using its speed and low-level agility, and Doolittle decides to neuter it. He strips away its superpower, makes it fly straight and level where its speed advantage is minimized, and forces it to compete with heavy bombers. Why on earth would Doolittle strip away their superpower and put them back up in the clouds?
It's a great question. And it is entirely counterintuitive when viewed alongside the overwhelming success in the Pacific. But to understand Doolittle's decision, we have to recognize the stark differences in the battlefields.
Okay, lay it out for us.
The Pacific was a war of vast oceans and flat jungle canopies against an enemy whose anti-aircraft technology, particularly early in the war, was mostly localized to ships and specific airfields.
Right.
The European and Mediterranean theaters were fundamentally different.
Because of the German flak network we talked about earlier.
Precisely. The density, the overlapping fields of fire, and the sheer volume of German anti-aircraft artillery in Europe and North Africa were vastly superior to what the Japanese had deployed.
It wasn't even close.
Right. A German defensive position wasn't just a few machine guns. It was a scientifically calculated grid of rapid-fire 20mm and 37mm cannons. If an A-20 flew straight and level at 50 feet across a prepared German defensive line in Italy, it wasn't a daring raid. It was a suicide pact.
Oof. Yeah, that makes sense.
Furthermore, the terrain in Italy and southern Europe is highly mountainous, with deep valleys and dense urban environments. Skimming the trees in a mountain pass while taking fire is infinitely more dangerous than flying low over the open ocean.
So Doolittle wasn't necessarily wrong. He was just managing a different kind of war. He couldn't afford to bleed out his experienced pilot roster trying to replicate Pacific tactics in a theater where the air defense infrastructure was explicitly designed to shred low-flying aircraft.
Exactly. It highlights the constant tension between frontline tactical innovation and the top-down realities of theater command.
But, you know, the operational necessities of the European war eventually forced the A-20 back to its roots anyway.
They did. As the Allied buildup in the British Isles intensified ahead of the invasion of Europe, the A-20 groups, including the 409th, 410th, and 416th bombardment groups, they transferred to the 9th Air Force.
And as they prepared to support the Normandy landings, the tactical doctrine shifted once again.
Right, because as the Allies hit the beaches on June 6, 1944, the heavy bombers up at 20,000 feet struggled with cloud cover and accuracy.
The troops pinned down on Omaha Beach needed close air support. Fast.
So the A-20s drop back below the clouds, they get back in the mud, they start providing direct, low-level tactical support, bombing enemy troop concentrations, rail junctions, and infrastructure right behind the invasion beaches.
They basically returned to the exact role the airframe was optimized for.
Exactly. There are actually incredible operational photographs from June 7th, the day after D-Day. They show A-20s completing bombing runs directly against the headquarters of German General Dietrich Krauss.
The commander of the 352nd Infantry Division.
Yes, they were hunting the nerve centers of the German defense, operating right down on the deck.
It's just an incredible vindication of the aircraft. But as we look at the scope of this deep dive, the thing that really astounds me is the sheer global footprint of this airplane.
It was everywhere.
Truly global. We've talked about it fighting over the tulips of Holland, the jungles of New Guinea, the deserts of North Africa, the mountains of Italy, and the hedgerows of France. It was flown by the British RAF, who used it heavily until the Mosquito came along. It was flown by the Free French forces, returning to fight for the country it was originally designed for. But the most staggering geographical footprint of the A-20 involves a completely different ally.
The Soviet Union.
Yes.
It is a little-known fact that the largest single operator of this American-built light bomber wasn't the United States, it was the Soviet Red Air Force.
Oh, that's wild.
The sheer scale of the Lend-Lease program with the Soviets is difficult to even comprehend. And the logistics of how these specific aircraft got from factories in the United States to the Eastern Front is just an epic saga in itself.
Oh, we have to talk about the LSIB route,
Ah.
the Alaska-Siberian air ferry route. Initially, some planes were shipped via ocean convoy to Murmansk, which was incredibly dangerous due to U-boats. But the primary method became flying them.
Imagine the logistics of this.
I mean, think about it. A Douglas A-20 rolls off an assembly line in California or a factory in the Midwest. American pilots, very often, the Women Air Force Service pilots, the WASPs, ferry the aircraft up through the United States to Great Falls, Montana.
Right.
From Great Falls, male ferry pilots take over. They fly them through a treacherous chain of airfields in the Canadian wilderness, up into the Yukon, and finally into Fairbanks, Alaska.
And the environmental conditions along that route were brutal. We are talking about flying twin-engine planes through blizzards over vast stretches of unpopulated tundra.
With temperatures routinely dropping to minus 40 degrees.
The cold was so profound that hydraulic fluids would freeze.
Yeah.
Engine oil would turn to sludge. Pilots risked frost by just touching the metal controls in the cockpit.
And Fairbanks was the handover point. You have these American pilots landing these freezing planes, and waiting for them on the tarmac are Soviet pilots. There is a massive language barrier, a cultural divide, but a shared mechanical objective. The Americans sign the planes over. The Soviets literally paint their red stars right over the white American insignia.
And then the Soviet pilots take off. They fly across the Bering Strait into the vast, desolate expanse of Siberia, eventually arriving thousands of miles later on the Eastern Front.
And the Soviets absolutely loved the aircraft, didn't they?
Oh, they loved it. They didn't care about the doctrinal debates between Jimmy Doolittle and George Kenny. On the Eastern Front, the air war was almost entirely tactical.
Focused on close air support for those massive armored clashes on the ground, like at Kursk.
Exactly. The A-20, with its rugged twin engines, its speed, and its ability to absorb punishment, was perfectly suited for the brutal, low-level interdiction missions the Soviets demanded.
So they used it to hammer German tanks, supply lines, and artillery positions relentlessly.
Thousands of planes changing hands in the frozen wilderness of Alaska to go bleed the German army dry on the Russian steppes.
It's an incredible testament to the industrial and logistical might of the Allies. But even as the war ground into its final months in 1945, the A-20 crews, especially those original Pacific innovators, they never lost that aggressive, rogue spirit that Pappy Gunn instilled in them.
No, they didn't. There is one final combat anecdote that I think perfectly encapsulates the DNA of the A-20 pilot.
Let's hear it.
This takes place in April 1945. The Japanese Navy is practically non-existent at this point, but Allied air power is still hunting the remnants of their logistics. Colonel Dick Ellis is the commander of the 3rd Attack Group.
Wait, the very same legendary unit that pioneered the nose gun modifications?
The exact same unit.
Amazing.
So Ellis is leading a long-range anti-shipping strike. It's a mixed formation. He's flying with a small element of 3 A-20s, and they're supposed to be supporting a larger force of B-25 Mitchell bombers.
Okay.
The tactical plan is simple. The B-25s, carrying heavier payloads, will strike the targets first, and the A-20s will follow up. But the Pacific weather intervenes.
Of course it does.
Ellis and his 2 wingmen lose visual and radio contact with the B-25s. They are completely separated from the main strike force.
Now, standard operating procedure dictates that a small separated element like that should immediately abort the mission, right?
Absolutely. You do not engage an organized naval force with only 3 light bombers. The mathematical odds of survival, let alone success, are negligible.
But Colonel Ellis doesn't turn back.
He does not.
He and his wingmen, Lieutenant Colonel Charlie Howe and Major Ken Rosebush, they just continue the hunt. And they stumble upon a small Japanese convoy operating alone. It consists of a cargo ship protected by 2 destroyer escorts.
And again, destroyers are floating anti-aircraft batteries designed specifically to shoot down planes.
Right. Most pilots would radio the coordinates to Fleet Command and fly back to base. Ellis, Howe, and Rosebush look at 3 warships, they look at their 3 planes, and they decide to attack.
It is an act of breathtaking tactical audacity.
The sheer audacity.
They drop right down to the wave tops, executing the exact skip bombing and heavy strafing runs they had perfected over the last 3 years. They fly directly into the combined anti-aircraft fire of 3 warships.
3 planes, 3 ships, and they execute the attack flawlessly. They skip their bombs into the cargo ship, sinking it. Then they turn their guns and their bombs on the escorts. They sink the first destroyer. They sink the second destroyer.
Total victories.
3 light bombers completely wipe out a naval convoy by themselves with 0 American losses.
And the reaction from General George Kenney at headquarters was fascinating. It's entirely illustrative of the command dilemma.
How so?
Well, when Ellis reported back, Kenney was initially furious. Ellis had explicitly ignored orders to abort upon losing contact. From a strict disciplinary standpoint, it was gross insubordination that risked valuable aircraft and lives.
But how do you discipline a commander who just sank an entire enemy convoy without taking a scratch? You can't court-martial a guy for achieving total victory.
Exactly. Kenney recognized that you cannot argue with absolute success. He swallowed his anger and ultimately decorated all 3 crews.
Because at the end of the day, Ellis's rogue attack was the purest distillation of the A-20's operational ethos.
It really was. The aircraft's entire legacy was built by individuals who took calculated massive risks, ignored standard doctrine, bent the rules of engineering, and achieved the impossible.
Which brings us to a really poignant realization. If this airplane was so foundational to the Allied victory, if it halted the Japanese advance in New Guinea, rewrote naval warfare in the Bismarck Sea, blasted pathways through the Normandy hedgerows, and served as the backbone of Soviet tactical air power, why has it been so thoroughly eclipsed in our historical memory? Why aren't there movies about the havoc?
Well, history is a narrative usually written by the successors. The A-20, for all its brilliance and rugged capability, was fundamentally a product of late 1930s aeronautical design. It was a piston-engine light bomber in an era that was rapidly transitioning to larger payloads and eventually jet propulsion. Even before the Second World War ended, the Douglas Aircraft Company had already produced the A-20's replacement, the A-26 Invader.
Ah, the A-26.
Yeah, the A-26 was bigger, heavier, faster, and carried an even more devastating payload of guns and bombs. It took all the hard-won tactical lessons of the A-20 and packaged them into a sleeker, more modern airframe.
So the A-26 eclipsed the A-20 in the public consciousness because the A-26 went on to see highly publicized combat in the Cold War era.
Exactly. It flew extensively in the Korean War and even conducted counterinsurgency missions in Vietnam.
A handful of A-20s survived in secondary roles, but the aircraft's primary combat life ended with the defeat of the Axis powers. It did the grueling, dirty, transformational work of halting the enemy when the Allies were at their most desperate and vulnerable.
It held the line, rewrote the tactical manual, and then quietly stepped aside for the newer, shinier model.
So, as we synthesize this incredible journey, we really have to look at the massive arc of this machine. We started with an airplane designed to be a polite, high-altitude export for a rigid French military.
Right.
We saw it thrust into the terrifying flak-filled skies of Holland as a bloody statement of American resolve. We watched it get stripped down to its studs and completely re-engineered by a rogue mechanic in an Australian hangar because the supply chain failed. We saw it skimming the treetops of New Guinea, dropping parachuted bombs to shatter an invading army, and skipping explosives into the hulls of destroyers to redefine naval warfare. We explored the deep doctrinal clashes over its use in the Mediterranean, and we tracked its freezing logistical journey across Siberia to hammer German armor on the Eastern Front.
For anyone listening today, the story of the Douglas A-20 Havoc is really the ultimate historical case study in pragmatic adaptability. Its world-changing impact did not come from being perfectly engineered off the assembly line.
No, it didn't.
It certainly didn't come from a rigid adherence to pre-war doctrine or operational manuals. Its success came directly from the willingness of people like Papygun, George Kenny, and countless air crews to look at a flawed, incomplete tool, accurately assess the desperate reality of their operational environment, and ask the most dangerous, transformative question in any bureaucracy. What else can this do?
And the legacy of asking that question didn't actually die with the A-20. Think about modern military aviation. Think about the A-10 Warthog.
Oh, that's a great comparison.
Right. The A-10 is an aircraft built entirely around a massive forward-firing gun designed to fly low, take damage, and provide devastating close air support. The philosophical DNA of the A-10 wasn't born in a modern boardroom. It was born in an Australian hangar when Pappy Gunn bolted 6.50 calibers into the glass nose of a light bomber. The havoc proved that sometimes the most effective tool isn't the most elegant one. It's the one that's willing to get in the mud and do the dirty work. So, as you go back to your own projects, ask yourself, where are you following the manual when you should be rewriting it? Until next time.